All right, almost there, guys. Almost done. Time to start to look at basically tying everything together and look at our one last concept and how that can be altered. And that concept is something called biodiversity. Uh, now, I have a really simple definition here. What is biodiversity? And it sounds a little odd, but the variety of different life living in a defined ecosystem. Now, diversity means obviously a lot of different types and kinds of living things. So ecologists can go in, and we've kind of been doing this, and can measure and count how many of one kind of bug there is, how many of this type of bird there is, how much algae there is. And together, if you add up the amounts and the numbers of different types of living things, they refer to that as biodiversity. Well, so what? Why does that matter? We're going to start looking at that, and that's what we're going to use to measure. Sort of, we'll see in the next couple of days the health and the strength of an ecosystem. Like we just said, why would you even bother doing that and counting and studying it for any ecosystem? And if you, as I just said, you think about it, we've studied ecosystems and the populations there. We've looked at food webs, we've looked at limiting factors for populations. Why don't populations grow larger, or why did this population go down? And we've looked at that. And if we take a step back and look at all the different populations, remember everything's connected, that's going to start to be an indicator, this biodiversity of how's that ecosystem I'm studying, how's it doing? Is it healthy? Is it in good shape? Is it in great shape? Is it in terrible shape? Biodiversity is the way to do that. So we're going to spend a few days here looking at biodiversity, and then ease into, and actually today also start to look at how that can be changed and altered and what happens as a result. So ultimately, our next to last real focus question, I'm going to kind of combine the last two together, is why is this biodiversity so important in an ecosystem? So we're going to begin to look at that today. Now, um, and no, like we said, food webs, populations, the same slide. So if you think back to Mono Lake, you don't have to actually look at it, but we've spent a lot of time on that. And you start to look at, like, well, what do the birds eat? We've talked about that. And then what would happen if most of the brine shrimp disappeared? We've looked at those things. And I've asked you in the last week or so to start to look at, like, hey, what would happen if we did that with Mono Lake? We did it with our Quizzo Fun. And these kinds of questions here really fall under the giant category of biodiversity, because essentially, if something happens, as we've seen, if something happens to one population, that can affect other populations. So, if we go there, so think about this next question: why would it be helpful for an organism and ecosystem to have more than one food source? Like, think of a food web. If you eliminate, and we started to look at this yesterday and the day before, if you eliminate one food source, and that's all that you eat as an organism, you're in trouble. But if you eat a variety of different things, and something happens to one of your food sources, let's say brine shrimp, but I'm also okay because I eat brine flies and algae and small minnows, then maybe I'll be a little bit better off. I might be okay. Where if all I eat is brine shrimp and they're drastically reduced, my population is in trouble. Which, if my population goes down, it's going to affect others. So, what we're really going to be after here is trying to see and exploring and piecing together is why having a huge variety, or diversity of populations in an ecosystem is the best, is what you want. If you don't have a lot of diversity, that's really not good for your ecosystem. And we're going to see today, and then for the rest of the year here, the next several classes, why that actually is a problem. Because ultimately, we're going to end here with this. I'm going to show you our activity for today. The greater the diversity, the more resilient. If you think about what this word resilient means, it's kind of like when bad things happen, you can bounce back. So the greater the biodiversity and the variety, the stronger your populations are. The better off they're going to be able to deal with changes in the system, and the more sustainable. The longer that ecosystem can go on, the healthier it can be. Ultimately, the more biodiverse it is, the more easily it can recover from stress, when bad things happen. And we're going to start to look at that today. So to do that, what we're going to do, I'm going to ask you to go back here and to look at this. We're going to go back into our Gizmo. So you're going to go and click on the link that's provided, and you're going to input our class code. Oops. Now our class code for this is pretty simple. I'm going to pause this here. Going back there, sorry. Now our class code, what we're going to see here is this, and the code is in the description as well, G2Z8Z4. Now, when you click on that, you input that and click on to enroll. It's going to ask you like, okay, go ahead and create, taught by, you're going to be joining Orion Science. I need to create an Explore account. Now, you may have created one before, but I've deleted all of them so we can have enough people here. So you're going to create a temporary account. So I'm going to go ahead and create an account. I'm going to make one up here and say that I am Ricky Bubby, and my email address, who cares? I don't need to do that. My login information, I'm just going to say whatever, Ricky, well, I'll say bada 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 bada. And my password can be, I'm just going to say Orion Science, Orion Science. Now, actually, you know what? I'm going to make my password Ricky Bobby 3. Now, oh, that name is already taken. Ricky Bobby 99. Username is already in use. Okay, I'm going to go ahead and put that in. Now, it doesn't really matter. You're just trying to contain enough information here to be able to get into the system. So whatever you put in here, it doesn't matter. This is a one-time thing. So when I submit that, now that's going to give us access. Now I don't want to save that stuff. What you're going to be looking for, we already did these up here. You're going to be interested in these two interactives, and they're really kind of the same. We're going to go to an ecosystem, a coral reef, and we're going to mess around with abiotic factors, and we're going to do biotic factors. So you're going to be doing two different. Now I'm going to go ahead and click on this just to show you as an example here. If I show you one, you'll understand, you'll actually be able to understand all of them. So now there's a lot of stuff here. You can click on tabs up here. We're going to visit a coral reef. Now you have, it can give you graphs of data, so you can select all the different living things. I'm going to go ahead and click all of them so that I want to know these are all the different living things that are living there. You can go back to the coral reef. You can actually click on the organisms to find out more about them. If you choose like what the heck is this thing right here, I can click on that. It'll tell you, oh, that's a Nassau grouper. Oh, that guy right there is a queen angelfish. Whatever you want to do, boulder star coral. Now over here is where is the crazy part. This is where you can, in this drop-down box, you can change conditions, non-living conditions. You can change the ocean conditions. You can change land use, fishing, disease, invasive species. You can change a lot of different things here. Now, what I'm going to ask you to do, I'm going to just give an example here. I'm going to say that, let's say, for some reason, over the course of time, the ocean temperature starts to warm up. So it's starting at 27 degrees. I'm going to advance a year, let a year go by, let another year go by. And let's say that after 5 years, the temperature increases by 2 degrees Celsius, kind of a lot. And I'm going to let it go forward another 10 years. Now, there's no set length of time. I'd suggest letting it go for the course. The longer the time, the more you can see. And then here's where it gets interesting. If you go to data, we can start to see that, remember, we have our population, our percentage of everything's normal. But as we start to advance our years, notice that something's happening here. Our blue, the stoplight parrotfish, and our red, the staghorn coral, they're starting to go down. So we can actually, what we can do, notice I've zoomed out, I'm going to keep advancing the years, we start to see changes in our population. Now, what would happen if it gets even warmer? I warm it up to 30 degrees, and let's go ahead and see what happens. Now notice I start to see a huge drop off in whoever this red guy is, the staghorn coral. I can also see that I'm able to start to see a big drop off here in this guy as well. So what I'm going to ask you to do is we can return it back to our original settings. We can restart again. I'm going to ask you to change different things, like for example, even an invasive species. What happens if I introduce in the middle of this? Let's go ahead and advance our years. We can start to see all the stuff that's. We can start to see. Oh, look, our populations. Everything's happy. Everything's kind of staying around this 100% mark. What happens when I introduce this red lionfish right at year 20? And I start to advance the years. Oh my gosh, look at what's happening to my population. This red lionfish is going way above, but it's really starting to affect my stoplight parrotfish. It's making my queen angelfish go down. So we can start to see, look at what happens over time to our biodiversity. So we'd also want to think about, well, wait a minute, if all of these things are dropping off, like, oh, these died out, they're gone, how is that going to affect everybody else in the coral reef? So you can always click on summaries for what you have your settings at. Fish diversity is very low here. Now, how is that going to affect stuff? How would that affect the food web? How would that affect the environment? Right. So I'm going to ask you to go back and to do actually both of these simulations and to spend time messing around with them. What happens when you change biotic factors? Also, I'm going to go back and I'm going to ask you to do the same thing. But you can also change, excuse me, abiotic factors. You can also change biotic factors as well. So they're kind of the same thing. You have the ability here to change uh, information. Some of these are abiotic, the ocean conditions, land use. We can look at like humans, think of doing things like logging. How could logging affect coral reef? That's stupid. Agriculture, farming, was that really going to affect coral reefs? So I'd like you to run multiple trials and change at least one abiotic factor as well as one biotic factor. Like what would happen if we introduce this disease? Uh, that's a biotic factor. What would happen if we do fishing and we use net fishing or we focus on catching like half of the grouper? That's a biotic factor. Humans doing that. So ultimately, what I'm going to ask you to do is to change um, an abiotic factor and then see and explain what happens. And in the exit ticket, change a biotic factor. And all you're going to submit here is just tell me what'd you change? How did it affect biodiversity? What happened? What would happen to the coral reef over long term in the long run? All right, so we're playing around here. We're kind of playing God, and you have free reign. You can change whatever you want, abiotic and biotic factors here. Make sure that you do one of each and just play it out. Run multiple trials and see what happens. All right, and you're going to end by submitting the exit ticket. Good luck.